On this 2015 to 2025 F150 with the 2.7 EcoBoost, P0172 means the PCM may be seeing bank 1 as too rich and may be pulling fuel until adaptive fuel control reaches its lean limit.
The truck may just have a check engine light, or it can show rich running symptoms like roughness, fuel smell, hesitation, or poor fuel economy. Broadly, think air measurement, fuel delivery, purge flow, oxygen sensor feedback, exhaust or intake sealing, PCV influence, contaminated fuel, and wiring or connector problems. Start with the basic system checks, follow a structured diagnostic approach, and do not clear codes or reset keep alive memory before you capture the data you need. First, check what codes are present. For P0172, if it is part of the fuel control group and there are no unrelated codes taking priority, continue this path. If other codes outside that group are present, check what they mean first. Before clearing anything, record the ECT or ECT1 value from the captured conditions. That temperature is there so you can reproduce the operating conditions that set the fault, instead of chasing it cold when it failed hot, or the other way around. With the ignition off, do the hands-on inspection before getting buried in data. Check the air filter and housing for restriction. Inspect the intake tract from the MAF sensor to the intake manifold for leaks, cracked tubing, loose connections, restrictions, or damage. Look at the throttle plate for sludge or obstruction. Check vacuum hoses, tees, evap lines, the intake manifold and gasket area, EGR sealing, PCV integrity and correct valve application if equipped, exhaust leaks, oxygen sensor wiring and contamination, cross-sensor wiring, and make sure the dipstick tube, and oil fill cap are seated. If you find a vacuum leak, that sends you to the vacuum leak verification path. If you find another obvious concern, repair it, clear the PCM codes, and repeat the self-test. If nothing shows up, move on to injector imbalance testing. Next, run the relative injector flow test with the scan tool procedure. If that test is not available on the vehicle, follow the pass side of the decision. If it fails, install the fuel injector in question, reset keep alive memory, clear the PCM codes, and repeat the self-test. Then run the power balance test. If it fails on this type of fuel system, install a new direct fuel injection fuel injector, reset keep alive memory, clear codes, and retest. If both injector checks pass, test the evap purge side. Use the scan tool CPV check when available. If it is not available, install the fuel filler cap or remove the supplemental refueling adapter. Record FTP voltage. Start the engine. Command evap CP to 0%. Command evap CV to on at 100% duty cycle. And watch whether FTP voltage stays within 0.5 volts of the recorded value within 30 seconds. If the purge check fails, install a new evap canister purge valve, clear the PCM codes, and repeat the self-test. If it passes for P0172, go straight to fuel pressure testing. If the branch routing keeps you in the shared fuel trim logic, start the engine and monitor CHT, ECT, ECT1, IAT, long-term trim, and short-term trim for both banks. Stabilize the engine at the temperature needed to recreate the concern. If the captured temperature is not available, maintain the engine coolant temperature between 82 degrees Celsius and 101 degrees Celsius, 180 degrees Fahrenheit to 215 degrees Fahrenheit, and the intake air temperature less than 46 degrees Celsius, 115 degrees Fahrenheit. Add long-term and short-term trim together for each bank at idle. Then increase the engine speed to 3,500 RPM for 10 seconds, and do the same calculation at 3,500 RPM. The decision is whether the difference between idle and 3,500 RPM is less than 15% of the total value at idle. If this branch calls for a map check, turn the ignition on, record map V, start the engine, and record map V again. The map value needs to change. If it does not, pause this path and use the map diagnostic path instead of guessing. For a vacuum leak branch, monitor SHRTFT1 and SHRTFT2, restrict the vacuum lines one at a time for 30 seconds, and do not clamp or pinch a hard plastic hose. Use a vacuum cap or equivalent. If short-term trims drop greater than 15% when a hose is restricted, repair the leak path. After the repair,
compare the before and after SHRTFT values at the same recreated conditions. A drop greater than 15% verifies the repair direction. If not, a vacuum leak is still present, and you need to go back through the vacuum leak check. If this shared branch sends you to the suspect universal oxygen sensor circuit, key off, disconnect the universal HO2S connector and PCM connector, and diagnose only the suspect sensor. On the 2.7 EcoBoost, measure C172 pin 3 to C1232T pin 57 and C171 pin 3 to C1232T pin 59. Resistance should be less than 5 ohms. If it is not, repair the open circuit, reset keep alive memory. Now, treat the fuel system with respect. Relieve fuel pressure before connecting a mechanical fuel pressure gauge, because the system can still be pressurized with the engine off. Pressurize the system, start the engine, let pressure stabilize, then command the fuel pump to maximum output. The pressure has to be within the correct range for the vehicle being diagnosed. If you do not have that vehicle-specific range, stop and get the correct fuel pressure information before making the call. If pressure is not in range, leave this path and continue fuel pressure diagnosis rather than guessing. If pressure is in range on the 2.7 EcoBoost, disconnect the fuel injection pump connector, start the engine, monitor FRP, and command fuel mass DI to maximum. FRP should be between 345 to 827 kPa, 50 to 120 psi. If it is not, install a new fuel rail pressure sensor, clear the PCM codes, and repeat the self-test. In the shared fuel pressure logic, there is also an FRP to FLP comparison. With the fuel injection pump connector disconnected, monitor FRP and FLP, and the FRP PID should be within 138 kPa, 20 psi of the FLP value. If it is not, install a new fuel rail pressure sensor, clear the PCM codes, and repeat the self-test. If pressure checks pass, reconnect the pump connector and do leak down. Run the pump to maximum pressure. The fuel pump stays commanded on for approximately 5 seconds. Command it off, let pressure stabilize, record it, and watch it for 10 seconds. It should remain within 34 kPa, 5 psi of the recorded reading after 10 seconds. If it does not, inspect the tank, lines, and filler pipe for an external fuel leak. If no external leak is found and the path leaves this flow, pause, recheck the earlier diagnostic path, and avoid guessing at the next test. If the 10-second leak down check passes, keep monitoring pressure for 1 minute. The pressure should stay within 34 kilopascals, which is 5 psi, of the recorded reading for MRFS, or greater than 275 kilopascals, or 40 psi, for ERFS after 1 minute. If it does not, continue the fuel leak down diagnostic path. If a different branch sends you to crank signal interference checks, key off and inspect the CKP sensor harness for routing, alterations, incorrect shielding, electrical interference from other systems, radio frequency interference, and excessive audible generator noise. Repair any concern, clear the PCM codes, and repeat the self-test. For P0172 after leak down passes, check fuel quality. Use a 200 milliliter beaker and a 25 milliliter graduated cylinder. Put 5 milliliters of clean water in the beaker. Drain 22 milliliters of fuel into an approved clean container. Pour 20 milliliters of that fuel into the graduated cylinder, then add enough water to bring the total liquid volume to 24 milliliters. Stopper it, shake it, let it separate for approximately 3 minutes, and record the separation level. If the fuel does not separate, treat it as contaminated fuel, replace the contaminated fuel, clear the PCM codes, and retest. If it separates, subtract the water added from the separation level, multiply that result by 5, and record the ethanol percentage. As an example, if the separation level is at 14 milliliters, the percentage of ethanol in the fuel is 50%. If ethanol is present on a flex fuel vehicle, compare FFINF to the calculated ethanol percentage. It should be within 20% of the calculated percentage of ethanol. In the example, the PID value should be between 32 and 48%. If it is not, reset keep alive memory, start the engine, monitor FFLRND, and drive approximately 11.3 kilometers or 7 miles, or until FFLRND indicates yes. After that, cycle the ignition and check FFINF again.
it should be within 20% of the calculated percentage of ethanol. If it is, the vehicle can be returned with correct fueling guidance, and the customer should continue using the same fuel for the next 2 or 3 refuels. On a non-flex fuel vehicle, if the calculated ethanol is less than 25%, continue. If it is not, repair as necessary, advise the customer on the correct fuel type, reset Keep Alive memory, and repeat the self-test. After fuel quality checks, inspect the universal oxygen sensor side. With the ignition off, disconnect the universal HO2S connector and look for pinched, shorted, or corroded wiring and pins, oil or water contamination, crossed sensor wires, and a contaminated or damaged sensor. Repair any concern, clear codes, and retest. If it looks clean, check MAF behavior. Start the engine, monitor RPM, MAF-V, MAF-HZ, and MAF-flow. Run the engine up to 1500 RPM for 5 seconds. Bring it back to idle, and repeat that once. At idle, the MAF value should be within 30% of the normal value. If it is not, pause this path and diagnose the MAF and IAT side. If MAF is in range, reconnect the universal HO2S, get the engine into closed-loop fuel control, monitor RPM, EQ-RAT11, and EQ-RAT21, then increase engine speed to 2000 RPM for 1 second and return to idle. If the equivalence ratio PIDs switch from greater than 1 to less than 1, or from less than 1 to greater than 1, the concern cannot be duplicated at that time. If they do not switch for P0172, go to the PCV influence check. For that check, start with the engine at normal operating temperature. Monitor and record long FT1, SHRTFT1, long FT2, and SHRTFT2. Shut the ignition off, disconnect the PCV line at the intake manifold, and temporarily plug the intake manifold port using a suitable method. Restart the engine, let it idle at normal operating temperature, and compare the current trims to the recorded trims. If the trims shift and the rich condition is no longer present, install a new fuel injection pump, clear the PCM codes, and repeat the self-test. If the rich condition is still present, continue to the connector and oxygen sensor decision. If the original code check sends you into the downstream oxygen sensor circuit branch instead of the P0172 rich bank path, run that branch cleanly and do not mix it with the fuel trim diagnosis. Key on, start the engine, run the engine at approximately 2000 RPM, and maintain the engine speed for 3 minutes. If the related downstream oxygen sensor codes return, key off, disconnect the PCM connector, and test the suspect sensor circuit. For the 2.7 EcoBoost, HO2S12 short checks include C142 pin 4 to C142 pin 3, C142 pin 2, C142 pin 1, and C142 pin 4. HO2S22 short checks include C141 pin 4 to C141 pin 3, C141 pin 2, C141 pin 1, and C141 pin 4. Those resistance checks should be greater than 10K ohms. If not, repair the short circuit, clear codes, and repeat the self-test. Then check for opens. For HO2S12, measure C142 pin 1 to C1232T pin 77, C142 pin 3 to C123T pin 12, C142 pin 4 to C123T pin 27, and C142 pin 2 to C1035B pin 47. For HO2S22, measure C141 pin 1 to C123T pin 81, C141 pin 3 to C123T pin 11, C141 pin 4 to C123T pin 26, and C141 pin 2 to C1035B pin 47. Those resistance checks should be less than 5 ohms. If not, repair the open circuit, clear codes, and repeat the self-test. Next, with the ignition on, check for a short to voltage at C142 pin 4 and C142 pin 3 for HO2S12, and at C141 pin 4 and C141 pin 3 for HO2S22. Any voltage means repair the short circuit, clear codes, and retest. If no voltage is present, reconnect the PCM and both downstream oxygen sensors. Start the engine, allow the engine to idle for 2 minutes, monitor the matching O2S PID, and record it. The PID voltage should be less than 1.5 V. If it is not, go to the final downstream oxygen sensor connector decision.
If flex fuel learning does not complete when that branch is used, disconnect all PCM connectors, inspect for pushed-out pins and corrosion, reconnect everything so the connectors seat correctly, and verify the concern. If the concern remains, install a new powertrain control module. If it does not, the system is operating correctly at this time, and the issue may have been a loose or corroded connector. For the P0172 rich bank path, after the PCV influence check, key off, disconnect all PCM connectors and the universal HO2S11 and HO2S21 connectors, inspect for pushed-out pins and corrosion, reconnect them so they seat correctly, reset keep alive memory, and verify the concern. If the concern is still present, install a new universal HO2S, reset keep alive memory, and repeat the self-test. If it is gone, the system is operating correctly at this time, and the issue may have been a loose or corroded connector. In the downstream oxygen sensor branch, do the same connector integrity check for the PCM connectors and HO2S12 and HO2S22. If that concern is still present, install a new HO2S, reset keep alive memory, and repeat the self-test. If it is gone, treat it as a connector seating or corrosion issue that is not currently present. After any supported repair, clear the PCM codes, reset keep alive memory where the step calls for it, reproduce the captured operating conditions, and confirm P0172 stays gone. The clean path is: capture the data, inspect first, prove injector and purge operation, verify fuel pressure and fuel quality, then use sensor feedback and fuel trims to split between fuel pump influence, oxygen sensor feedback, connector issues, and the remaining fuel system paths. For more diagnostic training, visit stepdiagnostics.com.